right, so just to review the model problems given on this worksheet to help some of you guys out just in case. All right, so we're starting our trigonometry unit. Trigonometry, the extent to what we'll be learning is using trig with right triangles only and finding either missing sides or missing angles from this triangle. So this is just the intro to what we're using for trigonometry. So some trig functions are called sine, cosine, and tangent, which are found on your calculator right here, sine, cosine, tangent buttons, okay? Using these values, we can say that the sine function of an angle, which they're calling B, so we can say is here, is equal to the ratio of sides that are either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So depending on the function, they have specific ratios, so you can't change these around. So each function has a specific ratio, all right? So if you want to ever use sine, sine is always going to be opposite over hypotenuse. So meaning the opposites from this angle, you're looking at your angle and telling yourself what's the relationship. So in relationship, there's opposite, hypotenuse, this would be adjacent. If we're using cosine, cosine is only adjacent divided by hypotenuse. So if we're talking about B, we're still talking about the angle B. The side adjacent to it, or another word for adjacent is next to, and we've talked about this when we talked about angles, divided by the hypotenuse for only cosine. When we use the tangent function, the tangent of an angle B is equal to the ratio of the opposite side, so these are talking about sides, divided by the adjacent side. So this is opposite, this is adjacent, or again, next to. So these are like what you need to remember, right? This is equal to this. Cosine of the angle is equal to the ratio of adjacent over hypotenuse. Sine of an angle equals the ratio of the opposite side over the hypotenuse of a right triangle. Only right triangles. Okay, that's why we did Pythagorean theorem first, and now we're doing this. So the model is done for you. Identify the side adjacent, opposite to angle X, and the hypotenuse. So if we're looking at X, okay, I'm saying to myself, what's next to it, right? What's adjacent to X? Well, it's side A. This is adjacent. Okay, opposite to X. Opposite, it means you're going across. So that would be side B, which they have here. The hypotenuse is always the one that's opposite the right angle in the triangle. It's also the longest side, always. This, in the Pythagorean theorem, this was our C value. So this is our hypotenuse, okay? And that was done for you. So this was like the model. Let's go to the next model. All right, we have model 2. What is sine of X, cosine of X, and tan of X? So now they want you to actually use SOHCAHTOA. So SOHCAHTOA is just the shortened version of what I just taught you. So they're saying sine, which is where the S comes from, is opposite over adjacent, hypotenuse, which is what you learned on the front. So this little like SOHCAHTOA word is to help you memorize these, okay? This is SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, right? This is the ka. And the toa is tan equals opposite over adjacent. Okay, that's where the T, O, and the A come from. So it's just like a word to help you out. So let's look at the first one, sine of K. So if we're using sine, we know we have to find the opposite side over the adjacent side. So if I'm looking at K, what's opposite of it? Opposite is 4. Okay, I need the hypotenuse. What's the hypotenuse? 5. So that's how I got 4 to 5, and I simplified it to 0.8. Let's try cosine. So cosine of k. We know cosine has to be k, which is adjacent side, over hypotenuse side. So we need to find these two things. So according to k, what's next to it? What's adjacent? Which is 3. Divided by the hypotenuse, which doesn't change, which is 5. So 3 over 5 simplifies to 0.6. Okay, and the last one, I don't have a different color, but we'll just use tan, is opposite over adjacent always. So now, and according to k, what is opposite? 4 still. And according to k, what's the adjacent? 3. We've already labeled these parts already because k hasn't changed. So if k is not changing, we're keeping k in the same spot, you can just label what the hypotenuse, adjacent, and opposite is to make your ratios like easier to do. Okay? So I'll do the first identify for you. So what's the hypotenuse here? The hypotenuse, again, is that longest side opposite of the right angle. So this would be YZ or ZY. You can name it another way. The side opposite of angle Z. This means angle. So what's the side opposite this angle? XY. And what's the side adjacent or next to angle Z? So again, still looking at this angle Z, what's next to it? XZ. This is adjacent. Okay, so you're kind of just labeling that, both sides. All right. So as the first page, you're doing those for the second 2 problems, and then I'll help you guys with the first one. So which ratio represents, for part 3, I'll help you with number 1, but you have to do up to number 6. All right, so which ratio represents cosine of A in the accompanying diagram? So again, if you see cosine, you should be thinking of, so you have your little word here, SOHCAHTOA. We're using cosine, which is adjacent over hypotenuse. All right, so we're looking at angle A specifically. So I'm going to circle angle A. I want the ratio of sides of the adjacent side to A and the hypotenuse of this triangle. So the adjacent side to A, or the side next to it, is 5 over the hypotenuse, again, is that longest one, 13. So my ratio is 5 over 13, so that answer is 1. Okay, so be specific. They want the ratio, again, sine P. You're using so. You're using this. Oh my God. Okay. So again, looking at angle P, what is opposite and what's the hypotenuse? So you're trying to look for that ratio. This is just ratios. I want to see if we can find the opposite, the hypotenuse, and the adjacent. Okay? Same thing for 3. Sine of x, again, sine is opposite over hypotenuse. So find those two sides, find the ratio. Again, using the same angle, so you're using this angle for all 3. I want the sine of L, I want the cosine of L, and I want the tan of L. I want the ratios. Okay? There should be a number in the bottom and the top for those. Again, for 6. Okay? So hopefully that was helpful.